In this video of chapter electricity, we will learn Ohm's law and its application. At a constant temperature, the current I flowing through a metallic conductor is directly proportional to the potential difference applied across its ends. That is, V is directly proportional to I, or V is equal to Ri. This is the mathematical expression of the Ohm's law. This law was given by George Simon Ohm, whose picture you can see on your phone screen. Here, Ohm has used one symbol R, which stands for resistance of the conductor. Resistance is the property of a conductor due to which it opposes the flow of charges through it. The materials which offer less resistance in the path of flow of electrons is called conductor, while the materials that offer very high resistance in the path of flow of electrons are called insulators. This is the graphical representation of Ohm's law. If we draw a graph between current and voltage, then the graph would be straight line. The slope of this graph indicates resistance. More slope means more resistance, less slope means less resistance. This graph shows that V is directly proportional to I. Let's study the resistance of a conductor in detail. Resistance is the fundamental property of substances because of which they obstruct or oppose the flow of charge through them. The SI unit of resistance is ohm, that is shown by a symbol, heart-shaped symbol. Conductors have very low resistance while insulators have infinite resistance. Materials with zero or negligible resistance are known as superconductors. How the resistors look like that you can see on your screen. These are resistors which are connected in many electrical appliances used at our home. Let's talk about the factors affecting the resistance of wire or conductor. Resistance depends on certain factors. Resistance is directly proportional to the length of the wire. It means that longer wire has more resistance as compared to shorter wire. In other words, resistance is directly proportional. Length increases, so resistance of a wire also increases. Resistance is inversely proportional to area of cross section of the wire, that is thickness. It means that thin wires are more resistive than a thick wire. Mathematically, the dependence of resistance on these factors can be stated by the expression R is equal to rho L upon A. This P-shaped symbol is pronounced as rho and it is called the resistivity of the wire. Resistivity refers to the resistance of a wire in terms of its length and area of cross-section A. What is resistivity? It is the resistance offered by unit length and unit area of cross-section of wire. Its SI unit is ohm meter. Its value depends upon the nature of material. It means that the resistivity of copper is different from the resistivity of aluminium. But it is important to note that unlike resistance, resistivity does not depend on length and area of cross section of the wire. Means if the two wires, one is thin and other is thick, both are made up of copper, then they both have the same resistivity. Though their resistance value will be different because their length and thickness are different. Value of resistivity of few materials are given in the table. Silver, copper are good conductors because they have low resistivity values, while as you move downward in the table, you can see the resistivity value increases.